Hello, this is the section 3.4 lesson. In this section we're going to start doing some arithmetic with fractions, and specifically we're going to talk about adding and subtracting fractions. And the most important point that we're going to make here is why we need common denominators in order to add or subtract fractions. So first of all, let's review the definition of a fraction. Fraction looks like this: a over b. B is the number of pieces in the whole, and a is the number of pieces that we have selected or that we're doing something with. Okay. So let's do a simple example of adding fractions. And so it says you ate 3/8 of one pie and 2/8 of another pie of the same size. How much total pie did you eat? Well, we see that we're going to start off by eating 3/8, and then we're going to eat 2/8, so we need to add those together to figure out the total amount that we have eaten. Well, let's draw a picture of both of these fractions. So 3/8 means that we're going to take our pie here, we're going to cut it up into 8 equal pieces, and then we're going to eat 3 of those pieces, so 1, 2, 3. Okay. Now 2/8 means that we're going to take that pie of the same size, also divided it up into 4 equal pieces, or 8 equal pieces, and then we're going to eat 2 of those pieces, 1, 2. So now notice that we have pieces of the same size. We took the same whole, divided it up in the same number of pieces, and so all of these pieces are of the same size. They may not look like it in my picture, but they are all of the same size. And so to get the total amount of pie that we ate, well, we just need to count the total number of pieces that we ate. 1, 2, 3, 4, 5. And so this is going to equal 5/8 of a pie. So you see in the end here, what we ended up doing is we simply added the 3 and the 2. That gave us our numerator. The denominator is 8. We were able to add those numerators because we had pieces of the same size. That's what common denominator of 8 means. All of our pieces are of the same size. All right, let's look at a similar example with slightly different numbers. If you ate half of one pie and an eighth of another pie of the same size, how much total pie did you eat? So we're going to start off by eating half of a pie, and then we're going to eat an eighth of another pie, and so how much total? Well, let's draw a picture here. 1/2 means we're going to take a pie, divide it up into 2 equal pieces, and we're going to eat one of those pieces. Okay. Eighth of a pie means we're going to take that same size of pie and divide it up into 8 equal pieces, and we're going to eat one of those pieces. So we might be tempted to say that, well, we ate one piece here and one piece here, so we ate a total of 2 pieces. But the problem is that these pieces are not of the same size. Obviously, this is a much bigger piece than this piece over here. So we can't just add one piece to one piece because they're not of the same size. So we need to get pieces of the same size. So graphically, what we could do here is take this first pie and divide that up into 8 pieces like this. And so now we see that this first pie represents 4 pieces out of 8, so 4/8. And then this piece is still, or this picture is still 1/8. And so now we can add these two fractions together. We have common denominators, means all of our pieces are of the same size. So we're going to add the numerators. We're going to eat a total of 5 pieces and 8 pieces total in a whole. So we're going to eat 5/8 of a pie. So there's our answer. We ate 5/8 of a pie. So in order to add these fractions, we needed to get a common denominator. We needed a common denominator so that all of our pieces were of the same size. Once all the pieces were of the same size, we could simply add our number of pieces and we get our answer. Okay. So again, to summarize, to add fractions, we must have common denominators so that all the pieces are of the same size. So common denominators, the phrase common denominators and the phrase pieces of the same size mean the same thing. That's why we need common denominators, so that we have pieces of the same size. Now let's do another example that's going to involve subtraction. And again, we're going to stress the fact that in order to do subtraction, we have to have pieces of the same size. So if you put half a cup of water into a bowl, and then you scoop out a third of a cup of water, how much water is left in the bowl? So let's draw a picture here. We're going to put in half of a cup. So let's draw a box here to represent our whole, which is 1 cup. And we're going to put half of this cup into the bowl. So let's divide this up into 2 pieces. We're going to put one of those pieces into the bowl. And so now we're going to scoop out a third of a cup of water. Well, let's draw a picture of that. So notice that these two fractions have the same whole. They're both of a cup of water. So it's the same whole. Now we're going to scoop out a third of a cup. And so let's divide this up into 3 pieces, and we're going to scoop out this much. So we could think of it as though we put in this one piece here, and we're going to scoop out this other piece. So we can think of this problem as we're going to put 1/2 in, and then we're going to take out a third of a cup. So that's the arithmetic that we need to do, a subtraction of fractions. We put in this 1 cup, we take out, or we put in this one piece, we take out this one piece. But again, notice that these pieces are of different sizes. These pieces over here are smaller than these pieces over here. So we need to get pieces of the same size. In other words, we need common denominators. Now geometrically we can do that very easily. Let's draw 2 vertical lines here and 1 horizontal line here. And so we see that here this original fraction of 1/2 is equal to 3/6. We have 6 pieces total in our whole. We've selected 3 of those. And then over here we've got 6 pieces total. We've selected 2 of those, so 1/3 is the same as 2/6. And so now all of our pieces are of the same size. So we can think of it as though we put in these 2 pieces, and then we're going to scoop out 2 pieces. And so now we can simply subtract our numerators. 3 minus 2 is equal to 1. And 6 pieces in the whole, and so 1/6 of a cup of water is what's going to be left. So again, to do this subtraction, we needed pieces of the same size. Or in other words, we need common denominators. Once we got common denominators, we can simply subtract the numerators, and we're all done. Now, one last concept in this section is the idea of mixed numbers. So a mixed number is a number that looks like this, where we have both a whole number and a fraction. So the mixed number 2 1/4 means that we have, or means the same as 2 plus 1/4. Okay? So what does that mean? Well, that means we have 2 wholes and then 1/4 of the same whole. So let's draw a picture of this. So let's say this little box here represents a whole. And then we've got a second whole, so let's draw the same whole there. And then we've got a fourth of a whole, so let's divide and make another whole and divide it up into 4 equal pieces. And so we're going to select this whole, and then this piece from this third whole. So there's a picture that represents this mixed number 2 1/4. So let's work with the same number 2 1/4 and convert it to an improper fraction. So here's the picture that we just drew of that mixed number. We have our 2 wholes here. Now in this picture we divided these holes up into 4 pieces because we already divided this third whole into 4 pieces. And so we want to convert this to an improper fraction. Remember, an improper fraction is a fraction where the numerator is bigger than the denominator. And so as a fraction, we need to take the total number of pieces that we have selected here and put it over the total number of pieces in a whole. Well, in a whole we've got 4 pieces, so our denominator is going to be 4. Now notice that here we've got 2 groups of pieces, and in each one of those groups we have 4 pieces. So from right here we have 2 groups of 4, or 2 times 4. That's the number of pieces we have right here. But then we've got one more piece over here, and so we need to add that one piece to it. So there we go. 2 times 4 plus 1, that's the total number of pieces we've selected. 4 is the number of pieces in a whole. And so there's the fraction. Now let's do this arithmetic here. 2 times 4 is 8 plus 1 over 4, and then this is equal to 9/4. So there's the fraction, or the number, 2 1/4 as an improper fraction. So let's generalize what we just did in the previous calculation. So we started off with a mixed number that looked like this, a whole number a times a fraction c over b. And then what we did is we took the number out front times this denominator, a times b, and then we added this numerator, c, and then we put that over the original denominator, b. So there's a very simple algorithm or formula for converting a mixed number like this over to an improper fraction. So let's use this formula to add a couple of mixed numbers. Let's add 1 1/4 to 2 1/2. And so by our formula that we just had, 1 1/4 is equivalent to the improper fraction 1 times 4 plus 1 over 4. And then 2 1/2 is 2 times 2 plus 1 over 2. So now if we do this arithmetic, this is 4 plus 1, which is 5/4, and then this is 4 plus 1, which is 5/2. Okay. And now to add these fractions, well, we need a common denominator. A common denominator would be 4. And so this is 5/4. If we get a common denominator of 4, we need to take this times 2 and this times 2. And so this is 10/4. And now we have common denominators, so we can add these together. And we have 5 plus 10, which is equal to 15 over 4. So there's my answer as an improper fraction. Now let's quickly convert this over to a mixed number. And so 15/4, think about what that means. It means we're going to have a whole that we divide into 4 pieces, and then we're going to select a total of 15 of those pieces. So let's draw a picture of that. So let's take a whole here, divide that up into 4 pieces, and we need 15 of those pieces. Well, we don't have 15 of those pieces, so we need to draw another whole here. So here's a second whole that we're also going to divide up into 3 pieces. So now we've got a total of 8 pieces. We still don't have enough, so let's draw another whole there. 1, 2, 3. Now you've got a total of 12 pieces. We still don't have enough, so let's draw another whole here. 1, 2, 3. That gives us a total of 16 pieces. So now we don't need all 16 of those, we only need 15 of those. So we need, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So there I've selected 15 of those pieces. And so what we see there in the end is that I've got 1 whole, 2 holes, 3 holes, and then 3 pieces out of another whole. And so 15/4 is going to equal 3 holes plus 3 pieces out of another whole that's been divided up into 4 pieces. And so there's my answer as a mixed number, 3 3/4. So last thing here, let's state a couple of very important points to remember when adding and subtracting fractions. Number 1, to add or subtract fractions, we must have pieces of the same size. Or in other words, we must have common denominators. The second point is that each fraction must refer to the same whole. In order to add or subtract anything in general, they must be referring, both numbers must be referring to the same thing. In terms of fractions, they must be referring to the same whole. If they aren't referring to the same whole, then we're not going to be able to add or subtract those fractions, regardless of what our denominators are. Now in the activity in class, we're going to get some practice in dealing with this and looking at a word problem and determining, does each fraction refer to the same whole? If they don't refer to the same whole, then we're not going to be able to add or subtract them at all. So that's it for this section, for this lesson. Your assignment for next class period is to read section 3.4 from the textbook. Now the textbook is going to talk about decimals, and we're not going to talk about decimals in this class until we get to division. So just ignore any discussion of those decimals.